Okay, hi children, this is your Shaktivel Max teacher. So I told in the previous video, so I came now again with a 10 number of question, 1 marks from the chapter number 1, real numbers. Again, the 10 question we'll see from this chapter. Okay, right. So we are going with this. We'll be going with the question number 11. Already we saw 10 number of question from first chapter. So we'll be continuing with the 11th question now. Okay, children? Right. So express 140 as a product of is a prime factor. So 140 they are given. We have to express in the prime factorization. That's it. So we'll take a 140 first. We have to express in the prime factorization. Simple. Okay. You take this. First 2, if you are dividing now, see 7 2s are 14, then 70 is there. Again, if you are going with the 2 table, you will be getting 35, means half of the 70, or else, what is the 3 2s are 6, remaining 1, 5 2s are 10, like that. So it never, what is that, divisible with the 5, 2 table, I am going with the 5, okay. Now 7 times, 7 5s are 35, now 7 table in the sense 1. So 140, we can write 2 coming 2 times, no. So 2 power 2. Multiply 5 and 7 it's coming 5 and 7, that's it. So these are the prime factorization for 140. They asked to write prime factors, so these are the prime factors for 140. Understand? Right. Next question number 12. Question number 12, they are given root 18 and root 5. Root 18 and root 5. What type of number is it? Is it what type? Is it rational or irrational? That is their question. Rational or irrational? That is they are asking. Rational in the sense, the number which is in the form of P by Q, the very important thing, Q not equal 0, and P and Q belongs to integers. That is very important. Integers. It belongs to integers. Okay. Now see root 18, it's an integer or not, we have to check. Okay. First root 18, let me split. 9 into 2 I can write. Multiply root 5 is there. Multiply root 5. See, 9 I have a root. 9 I have a root. What it is? 3. 9 I have a root value 3. But this 2 I don't have a root. So you write in a root like this. Okay. This 10 also I don't have a root. You write like this. See, now 3 into root value I have. See, when I have root A into root B, I can multiply each other within a root. In a root I can multiply like that. So in a root 5 into root 2 in the sense I am getting root 10. So see, definitely it's not a rational, because root 10, it means root 2 it's a irrational. Root 5 it's a irrational. Product of 2 irrational, you will be getting sometime irrational only. Not same number. See, sir said product of irrational is a irrational, he said. See, root 3 irrational, root 3 irrational. Then it should come irrational only. No, sir, we are getting 3. It's a rational. Like that you don't think. Same irrational, when you multiple, you will be getting rational. Different irrational, when you multiply, you will be getting like this. Understand? So this is irrational. What, my dear? It's an irrational answer. It's an irrational, not a rational. They asked to check whether it is a irrational or a rational. I'm telling that it's a irrational because it contains root 10. Root 10, when you split, it coming root 2 and root 5. Both are irrational, so it will be irrational. Understand, children? Right. Next, I'm going question number 11. Question number 11 completed, 12 completed, 13 I'm going. Right. Question number 13, state whether 64 divided 455 will have terminating decimal expansion or non-terminating decimal expansion. That we have to check. They are asking. Terminating in the sense, I told you, the denominator which is in the form of 2 power m and 5 power n. That we have to check. The denominator alone. Suppose if it is in the form of 2 power something, 5 power something, we will say terminate. Otherwise, it's a non-terminating. That's it. So you take denominator 455. 455 will take, and we will check this prime factorization first. Okay. Now, see, 9 5s are 45, 1 5s are 5. 7 table it's coming. So 1 7s are 7, remaining 2 in the sense 13 times. So here 13. See, the denominator 455 consists 5, 7 and 13. See, other than 2, I'm getting 2 and 5, I'm getting 7 and 13. 7 and 13 I'm getting no. So what you will say? This is non-terminating and repeating. It's a non-terminating and repeating decimal expansion because the denominator is not in the form of 2 power m and 5 power n. That's what I'm telling. This is non-terminating and repeating. Okay. Next question number 14 we'll see. Okay. 14th question we'll see. 14th question, LCM of x and 18 is 36. See, two number LCM they are giving 36. So this is LCM 36. So LCM equal to 36 and HCF. See, this is HCF of this again the same number is 2. HCF of 2 number is a 2 they are telling. So the formula we knows very well, no? What is that? Product of LCM and HCF equal to product of the two number. This is applicable only for two number. I told you already. So LCM it's a 36 and HCF it's a 2 and A value x. A value here x and B value 18. So we have to cancel this. We have to cancel this. Okay. So 118. How many 18? 36. 2 times. That's it. So what I am getting now? 2 2s are 4, which is equal to x. So our required answer is x. They asked to find the value of x. We are getting x equal to 4. Do you understand, children? Right. Now I'm going with the question number 15. Okay. We'll go with the question number 15. Let's see what is the 15. How many irrational number lies between root 2 and root 3? And between root 2 and root 3, how many irrational are there? They are asking. See, we can say infinite irrational number. In between two number, any two number is given. How many rational is there? Irrational is there? If they are asking, definitely it contains many. We cannot able to find it. We cannot able to find out that answer. They are given root 2. Root 2 in the sense that is 1.414. And root 3 in the sense, it is 1.732. That we must know. In between only they asked, no, we can write many, I told you. How? Let me explain. See, this, in between in the sense, it should be more than root 2, less than root 3. That is the concept. So, more than root 2 in the sense, here 1.4 is there, you take 1.5. Okay, and 1.51, 0, 1, 001, 001, like that you can go. Or else 1.5, 1, 0, 11, 0, 111, 0, 4 times 1, like that we can. So many ways is there to write in what is that standard form of irrational. This is called the irrational number. See, irrational number in the sense, there is no terminating. It never terminate, and it never repeat. So terminate in the sense end no. So I'm giving dots. Okay. And recurring or repeating, both are same. There is no repeating number. Here 1 is there, 111, 4 times 1. There is no repeated value. That's what these are the, what is that, irrational number. In between these two, how many irrational number is there? In the sense we have a many. They asked to write any two of them. They asked, I have written like this. Okay, but infinite answer is there. In between any two they asked, we can write like this. Do you understand? Right. Next, see question number, what it is? Question number 16. 16 here it is there, you see. HCF of this number. HCF in the sense I told you, this is what is actually 3 power 2, 3 power 3. Product of least powered number. So, least power 3 power 2 multiply. 5 power 1, 5 power 2, then least power 5 power 1. So, that 9 into 5 which is equal to 45. 9 into 5 equal to 45. That's it. Our answer we got it. Do you understand, children? Simple. This is simple actually. HCF they are asking. HCF in the sense, the definition you must know. Product of common least powered number. That's it. Common are at the same time it should be contain least power. That both should be satisfied. Then you can write like this. Okay. That's it. And we'll go to question number 16. Okay. 16th we will go. 16th, what they are given? Explain why this number is a composite number. Why explain this number is a composite number they are asking. Right. Here 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 is given. This number we have to take. Composite number in the sense I told you. There is more than 2 factor. More than 2 factors. Which has more than 2 factor. We are telling it's a composite number. That is our aim. So we have to say it consists more than 2 factors. Okay. Right. After plus, there is a 5. Then here also 5. That 5 you take commonly outside. Then I have here 7 into 6 into that 5 I took outside. No, then nothing is there. You put 1. Okay. Here 4 into 3 into 2 into 1 plus this 5 I took outside. Then nothing is there. 1 you write. That's it. We have to multiply all those number. Then 5 into 7 6 are what? The 7 6 are 42. Okay. Then this what actually? 4 3s are 12, 12 2s are 24, plus 1. When you multiply this one, same only. And these together you multiply. 42 into 24. You multiply 4 2s are 8, 4 4s are 16. Okay. Again, 4 2 2s are 4, 4 2s are 8. You add this 8, 10, balance 1, 10. What I am getting? 1008. You just enter it. Here 5 is there. This is 1008 plus 1 is there. When you add plus 1, what I am getting? 5 into 1009 it's there. 1009 is there. But there is only 2 factor. There is only 2 factor. But definition is more than 2 factor it has. We can say it's a composite number. But it has exactly 2 factor. Don't worry. We can put 1. We can put 1. When you put 1, see 1, 2, 3. We have a 3 factor. So now we can say it's a composite number. They asked to explain why it's a composite number because it has more than 2 factors. So it is a composite number. Okay. What are they? 5, 1009 and 1. So you say it's a composite number because it has more than 2 factor, because it has more than 2 factor. More than 2 factors. That is very important. Okay. It's a composite number because it has more than 2 factor. That's it. Our answer is over. Now we'll go to question number 18. Question number 18, what they are telling you, see children, what are the possible value of remainder R? Remainder R, they asked to know. What is the possible value they are asking? What is the possible value? Possible value they are asking. Okay, let me write. And when a positive integer A is divisible by 3, divisor they are telling 3. See, as per the equal division formula, we have BQ plus R, where 0 less than or equal to R less than B. Here, B is the divisor. What children? B is the divisor. B is the divisor. So, divisor what they are given? 3. Then you put here 0 less than or equal to R less than 3 in the sin. Then possible remainder what I am getting? 0 above less than 3. So, R equal to I am getting 0, 1, 2, not a 3 because less than 3 they said. So, these are the 3 possible remainder for R. Do you understand children? That's it. Now we'll be going question number 19. Okay. 19 will start. 19 and 20 is there. Okay, we'll start this. Right. 19. Okay. Find the prime factorization of the denominator. For denominator, we have to find a prime factorization. Prime factorization, we have to find the denominator and of the rational number is given. See, rational number 8.39. 8.39. 8.39, how you will write in the P by Q form? When you multiple 10 in the numerator and denominator. See, I am multiplying both numerator and denominator, I am multiplying 10. I am multiplying, dividing, that is the concept. When you cancel this will be 1 and no. Question never change, so no problem. So what I am getting after multiply, the decimal will go. So 839 divide 100, that's it. This is I am getting. But here what they asked, you no need to simplify and all. They asked prime factorization of the denominator. Denominator prime factorization we have to find. That's it. You take this 100 prime factorization what? 100 equal to, when you divide by 2 you will be getting 50. Again when you divide I am getting 25. This 5, 25 in the same 5, again 5 you will be getting 1. So denominator 100 prime factorization 2 power 2 into 5 power 2. Why I am writing 2 power 2? Because 2 consisted 2 times. And 5 consisted 2 times, so that I am writing 2 power 2, 5 power 2. Do you understand? So, denominator prime factorization is 2 power 2, 5 power 2. That's it. Okay. Now, last question from this video. In this video, last question I am coming. The numbers 525 and 3000, both are divisible only these numbers. This both dividing only these numbers are. Okay, so it means these are the number for factor for this both number 525 and 3000. And what they are asking, what is the HCF of 525? They are asking. What is the HCF of 525? Nothing. We have to normal. They are giving for confusing these things. You no need to worry about this. Okay, no need to worry. You just take 525 and 3000. You make it prime factorization. You find normally what is the HCF. Okay, you take 525. Here I am giving. This answer I am giving. What is that? 525 you take, divide by 5. So what I am getting? 1 time, 2 knots dividing 5, then 0, 5 5s are. Okay. Again, when I am going with the 5, 2 time, 1 time. 3 if I am taking 7 3s are. If I am taking 7, I am getting this. So 525. 525 equal to what I am getting? 3 into 3 coming one time, 5 coming two times, then 5 power 2, it's 7. That's it. I have written all the factors for what is that? 525. Next you take 3000. 3000 you take. 3000 equal to, how you will write this actually? See, 3 into 1000. 3 into 1000. 3, that's it. You write as it is. 1000 we can write 10 power 3. 10 power 3. 1000 in say. So 3 into 10 power 3 in the sense 10 2 into 5. 10 means 2 into 5. The power 3 will come for both. Then 2 power 3, 5 power 3 you will be getting. If you not understand this, go with it like this pattern. Same pattern you go, but it will take time. Now we'll see, here we have to find the HCF. No? HCF in the sense common number. Common number we have to take. See, there is a 3, here also 3. So you take 3, first multiply. Other than that, 5 power 2, 5 power 3. Least power we have to take when we have a common. So least power 5 power 2 multiply. Anything else? That's it. There is no common. 2 is here not is there. 7 is there, here not there. That's it. You leave it this multiply. Now 3 into 5 square in the sense 25. 25 into 3 in the sense 75 I am getting. So 75 is the HCF. 75 is the HCF for the given question. Do you understand, children? That's it. Again, with another 10 question, I will come with the next video. The part 2 video is over. In part 3, I will meet you again. Thank you, children. Stay with the Vidyalakshmi YouTube channel. Subscribe and share these videos to your friends also. Thank you. Let's see in the next video. Bye.